And then boom, there you go. Your antiderivative should be x e to the x minus e to the x. And then plug in your limits. 0 to 1. Ta-da! Oh, we evaluated that one already. When I plug in 1 here, you're going to get 1, you're going to get e to the 1 minus e to the 1. You get 0 when you plug in 1, so that's a little weird. When I plug in 0, I get 0 minus 1. And keep in mind, it gets multiplied by that ln2. So with all these nested negatives, that ultimately, all that work for 1. So 1 times ln2, you get natural log 2 as your ultimate answer there on that one.
Sweet.
So when you can, the big premise here, I know we spent a lot of time on that shortcut because some of you hadn't seen it, and that's supposed to be the letter P. It looks like a D, but it's a P, I promise.
I got the integral wrong before that.
So if the integral can be factored as a unique function of x times a unique function of y, and you're integrating over a rectangle, separate them and turn them into two integrals, and then just multiply the result together at the end. All right? I'm gonna let you guys try one. I'll give you about 4.3 minutes, see if you can hash that one out. Maybe 112 minutes. And I'm going to take a sip of my pepper. Can you zoom in a little bit more? Some of you may have forgotten your glasses, apparently. I see some squinting.
Which one are we supposed to do first?
Oh, this one? Oh, you mean in terms of which order? Arbitrary. The easiest one. I'm writing the answer right here. Feel free to come up and check it if you want. It's there. If some of you are seeing these notes for the first time, I can show you at the end of class where these come from on our D2L page if you're curious about that. Having to dust off some antiderivatives you've forgotten in a while. Yay, nay.
No.
Oh no. And this one involves one of them. Oh, forgotten integrals. Some that are often kicked under the bus. Yeah. One of these leads to a natural logarithm, one of these leads to an inverse trigonometric function. Which of these two leads to a natural logarithm?
The
Top.
No, the one on the bottom.
Prosperity.
Respect to what?
The
Well, I'm just
trigonometric
saying,
is the
just
one on
calculus
top.
2, these are just generic integration
Is
formulas.
Is that the tangent? The one on the top?
This one leads to inverse tangent.
Thank you.
This function is
I'm sitting
antiderivative,
here looking
which
at
you
my
do
computer.
need for this problem. This becomes inverse tangent, arc tangent, or writing it this way, of u. This one, if you make the use of, and unfortunately I've already used the variable u, if you let u equal your u squared plus 1, you gotta fudge a 2 up top. I use quotations for my fudging factors, and this becomes the integral of 1/2, 1 over w, I guess. So it leads to a natural log in your antiderivative. And unfortunately, you do not need this one for that problem. You do need this one though. That's the one that usually gets kicked under the bus.
Yeah, I did get that answer, I just forgot to find values for the first stage.
So another thing that gets kicked under the bus from an earlier class, trigonometry, inverse tangent of root 3. How many remember how to get that? You got a very expensive calculator you spend a lot of money on. If you don't remember that that's pi over 3, and I kind of rather just not go on the internet for posterity because it's kind of a cheat. But anyway, the ultimate cheat for evaluating inverse trig functions is to switch your calculator to degree mode. Remember, for math purposes and function analysis and domains and range, you always have to use radian measures for angles. But if you switch to degree mode on your calculator, and I'm already in degree mode, so good to go. So if you need to evaluate the inverse tangent of root 3 and hit enter, it gives you a degree measure of 60. So you need to get this and say, well, the radian measure is pi over 3,
Okay,
so I need to
so you-
write pi over 3 as the evaluation of the function. So you need to at least remember your degree radian equivalents, okay? And that should pop up in this problem as well, because if you didn't get to the answer I have back here behind the canvas is 4 pi over 9. Anybody get that?
9?
You got that eventually? Okay.
Yeah.
What
I
happened
do.
then?
Well, I just thought, I just used u
3.
substitution and said u is equal to 1 plus y squared.
Okay. Well, how many of you recognize that this is factorable? And use the fact that you can use a function of x and a function of y separately as two separate integrals.
Oh, that's what I did.
Okay, yeah, this one happens to be, if you split this up as 1 plus x squared numerator times 1 over 1 plus y squared denominator, it's a separable,
Yeah, but I don't know, I got 4 pi over 3. I didn't do something with my 3.
let's see, the x one's easier. 0 to 1 for the function 1 plus x squared dx times the integral from 0 to root 3, the integrand there is 1 over 1 plus y squared dy. So if you integrate these one at a time, that one's just good old polynomial. So that gives you x plus 1/3 x cubed. So I don't doubt any of you were having any trouble getting 4/3 from that one. Okay, I like the thing here where I got that one okay. This is one of the, like I said, this is one of the ones that kind of gets kicked under the bus. Even though every calculus textbook I've ever seen
Oh, because it's 5 over 3.
describes,
Yeah, with the very last little arithmetic.
every calculus textbook I've ever seen has that integral, that antiderivative, in what's called its basic forms. I mean, admittedly, it's the, one of the last ones. It is the last one here, but that's one of the allegedly basic forms of antiderivatives for all the functions you need to keep
Natural
in memory.
log equals
So-
plus tangent.
I figured I'd shake a little dust off with this example. That goes to, so multiply these together. So the antiderivative there will be inverse tangent y. You want to evaluate that at root 3 first. So this is where using the little degree mode cheat on the calculator might have come in handy. That's cool. Yeah. So you got the 4/3 from your x integration, and then this becomes, and like I said, just go to degree mode, type in inverse tan root 3, 60 degrees there on the calculator, and I write pi over 3 radians on the problem. Because when you're dealing with the trig or the inverse trig functions, your domains, your ranges need to be, well, I guess dimensionless values, not degree measures. So that's why you use radian measures when you're dealing with the mathematics and the function analysis with the trig and inverse trig. So
What? Good catch.
that becomes pi over 3 minus 0. And so that's how I got 4/3 times pi over 3 equaling 4 pi over 9. Okay. So far so good? Let me, well,
That's
I
great.
actually wanna, I wanna stop. I think I'm giving you enough to digest.
Is it-
It's only about a half an hour earlier, but I think I wanna, just maybe let you begin your 3-day weekend early.
Good man.
Cause, I mean, keep in mind, you got class off tomorrow, so.
Sounds good to me.
Why do we have
And you
class
gotta-
tomorrow?
well,
Easter weekend?
I mean, it's technically Good Friday, but I think it's just to accommodate the common calendar or to make it a calendar adjustment. The last several years, we have not gotten Good Friday as a holiday. This is the first time we've had Good Friday in a number of years, so.
On top of
we
all the
usually
time we've
get
already
it.
had off.
And I guess I'm making up for lost time. I know, we had all those ice days and now we're getting Good Friday. I
Right.
figured they'd rescind it.